Okay, so we're starting statistics and the normal model. So notice that we've been doing statistics with box plots and histograms. Now we're moving into the normal model. So let's go through this. Now 90% of this video will be review. So let's quickly go through it. So our objective is we're going to calculate statistics and percentages for the normal model. And what that means is versus skewed models. So for the next several days, we'll be working just with the normal model. So let's review. Statistics that measure center. We know this. We're just going to write it and review it. Mean. It's symbolized by X with a line on top on your calculator. It's an average. And how do we get it? We add up all values and divide by the n. N being the number of values. Okay, we know this. The only new thing here is perhaps that n, you'll find it on your calculator. That's how many values were in the data set. Okay, median. Median is the middle. It's the middle number. How do we get it? Write data values in chronological order. I'm going to squish in here. And get the middle value. Now what happens if you have an even number of values, therefore you have two numbers in the middle? Well, what you do to find your median is you get an average. Average two middles. Okay, if you have two middles, you just take an average. I think we had a problem yesterday where the two middle numbers were 60 and 62. So you add those two, divide by 2, and you get 61. All right, mode. Mode is most. So that's what it is. It's the value occurring most often. And we get the value for mode by looking at the data. It's not in the calculator. You just have to look at the data and say which of these occur most often. Okay, range. We've got range and standard deviation. Now just for your reference, all of this material is in chapter 11.11-7 if you want to get more examples or read more in depth. Okay, range. We know this. This is another word we've been using is variability of the data. How do we get it? It is the maximum value minus the minimum value. So what is the range of the data? Okay, now we're getting into something new, standard deviation. We've not talked about this yet. And by definition, standard deviation is answers the question, how widely spread is the data? Is it all together? Is it widely spread out? We can measure this of how much the data varies. Okay. So what we're going to do is practice with an example. So let's first find out how many data values we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So n equals 14. Okay? Now, let's enter that data into our calculator. So we're going to do this together. We've done this for box plots and histograms. So we're going to use the stat function, hit the stat key. We're going to edit. Now, when we have data already in there, go up to the top, clear, enter, move over. Oop, not up there. All right, got to be all the way up there. No, really. All right, There we go. All right, over to L1. Let's put in our data. Make sure you give a check at the end that you have the right amount of data in there, because varying by one number will give you a wrong answer. All right, yes, I know that there are 14 numbers in there because now I'm on the 15th entry. Okay, so remembering how we get this information, we go to Stat, we go to Calculate, and we hit the variable statistics. It's on 1, enter. Enter, enter, enter. Okay. So the very first value at the top you see is the mean, x with a line on top. So what is our mean? 6.7. Now scroll all the way down. This gives you your 5-number summary. So anything that's in there is going to be down at the bottom. So our median value, we can read right off there, is 7.5. Our mode, calculator doesn't give us mode, so we look at it and we say, what numbers are repeated? Well, 8's repeated, 1, 2, 3. 9 is repeated 1, 2, 3 times. We have 8 and 9. Therefore, this is bimodal. It has 2 modes. Okay? Now, on to standard deviation. So let's scroll back up. If we scroll up to the top, we've got some things we haven't worked with yet. This is a sum, the sum of x. Don't worry about that one. And then right here, above n is 14, we have 2 measures of standard deviation. Now we're going to use this one, the one that has the sigma x in front of it. Okay? So let's say the standard deviation is 2.7. Okay. The range of the data, the maximum number is 12. The minimum number is 2. Therefore, our range, box that in, is 10. So that is how we get all of these data points. Stat, calculate 1, and then you'll have all your data. All right, so moving on. We've talked about distribution with box plots and histograms. Looking at it, this is what we call, the first one is what we call a symmetric distribution, and typically what we call the normal model. And that's what we're going to be working with over the next several days. We've learned that this graph shows a right skewed distribution. The name of the skew follows the tail. The tail is to the right, therefore it's right skewed. In this one, the tail is to the left, and you are left skewed. Now what does it mean to be right skewed? It means that the mean, if you're right skewed, the mean is greater than the median. And with a left skew, your mean is less than your median. So we do have to know that. When data is symmetric or centered around the middle value with no skew, we call it a normal distribution of the data. Normal distribution, or sometimes it's called a bell curve. We've talked about grades being in a bell curve. I'm sure you've heard that. So that's what we're going to be dealing with. Some examples of real life data that follow this curve and not these curves are height, the height of men and women, weight, SAT scores, IQ, batting averages. There's lots of them, but this is just a few. We'll be working with these as examples of the normal model. Body temperatures, one more. Okay, so there we go, some examples, and we will be working with this in class tomorrow.